Okay. Good morning, afternoon, or evening, everybody, depending upon where you are joining us from. This is your host, Jennifer Brennan. You have joined the NASA Earthdata webinar, Simplified NASA Earth Science Data Access through OPeNDAP. It's 2 p.m. Eastern time, so we'll go ahead and get started. First, let's begin by going over a few housekeeping items related to this webinar. To ensure the best audio experience, the conference has been placed in silent mode. If you have any issues or questions, what I'd like for you to do is enter those into the Q&A pod located on the lower right-hand side of your screen. This works like a chat. The webinar will be recorded and posted to our NASA Online Adobe Connect event catalog, as well as to our NASA Earthdata YouTube channel within a few days of completion. I do plan to provide these URLs to you at the end. All presentation files will also be available for download at the end of the webinar. The webinar itself will be 1 hour long. We've allocated 45 minutes to the presentations and live demonstrations with another 15 minutes for the Q&A period. After the speakers have finished their presentations, we will move to the final set of polling questions, and then from there, we'll move directly to the Q&A period. As mentioned earlier, you'll have an opportunity to ask your questions throughout by using the Q&A pod. Questions will not be answered using the raising hand function. It has been disabled. Again, we'll take all the questions at the very end using the Q&A pod. What I'd like to do next is move to our agenda and a introduction. Our first speaker today is Yaxing Wei. Yaxing is a scientist at the NASA Oak Ridge National Laboratory Distributed Active Archive Center, or the NASA ORNL DAAC. He will provide an overview of OPeNDAP and also highlight the 3 instances to be covered during today's webinar. He will then follow with a live demonstration for the THREDDS data server, which is implemented at ORNL DAAC. We will then transition to our second speaker, Aaron Fries, who is a data scientist for the NASA Land Processes DAAC. He will highlight middleware services at the NASA LPDAC and demo AppEEARS, which is the LPDAC instance of OPeNDAP. Finally, we will transition to our last speaker, Matthew Tisdale, who is the NASA Atmospheric Science Data Center, or ASDC DAAC, Advanced Architecture and Engineering Team Lead. Matthew will provide examples of how to use client tools for accessing OPeNDAP. I would like to now introduce our first speaker, Yaxing Wei. Yaxing?
Hello, thank you. Thank you, Jennifer. This is Yaxing Wei from the ORNL DAAC. I will start with a brief introduction to OPeNDAP and talk about why you need it. OPeNDAP is a remote data access protocol that provides users simple, remote access to large collections of data via the internet through HTTP. So why do you need OPeNDAP? It can simplify access to and usage of a wide range of NASA Earth science data. For example, MODIS, ASTER, Major North American Carbon Program, and many, many more in your research. And OPeNDAP has many nice features that make access and usage of data simple and easy. The first one is remote data access. Through OPeNDAP, users or clients can access remote data via URLs, and this will save a lot of local disk space, especially when large data are needed. For example, you need to perform some data analysis in your workspace, such as MATLAB, R, or Python, and need to use large collection of NASA Earth science data. As long as the NASA Earth science data are served through OPeNDAP servers, you can directly load those remote data into your workspace, and you don't have to download those data files beforehand. And the second feature is that OPeNDAP allows you to subset data, and you can access a portion of data as needed. For example, for multi-dimensional data, you can pick certain variables, limit index ranges, skip indices, and reduce dimensionality. And another useful feature is that OPeNDAP allows dynamic aggregation. On the server side, multiple data can be aggregated into single virtual data, and this simplifies data management on the server side and also simplifies access for users. And transparency is another great feature of OPeNDAP, and in my opinion, it's a very important one. With simple and common data model, users do not need to worry about the different data formats in which the remote data are stored. And this feature greatly aids the use of NASA Earth science data for data users, especially when the user's research involves multiple different data products. And data products available from the ORNL DAAC, from the LP DAAC, ASDC, and other NASA data centers are all archived in different data formats and different versions of HDF, NetSDF, HDF-US, GRIP, CSV, etc. But the OPeNDAP servers can dynamically map them onto a common data model. So you don't have to worry about the different data formats. And OPeNDAP is widely supported and has been adopted by NASA as a recommended standard. There are many different implementations of the OPeNDAP protocol, such as Hierarch, THREDDS data server, and Earthdata. But no matter which implementation, they support the same protocol and interface. And for data users, more importantly, there are many clients already support OPeNDAP. For example, NCL, CDAD, MATLAB, R, Python. And it's good to see that we have two winners in the polling question at the beginning of the webinar. We have most of the people that are familiar with Python and R and use that as programming languages to deal with NASA Earth science data. Python and R have good support for OPeNDAP protocol. And this means it's very possible that the tools you are familiar with already support OPeNDAP. In today's webinar, we will do live demonstrations to introduce OPeNDAP services set up at 3 different NASA DAACs, the ORNL DAAC, the LP DAAC, and the ASDC. We will show you how to explore OPeNDAP servers to find, visualize, and access data of your interest. And more importantly, we will show you how to access and use data through different types of OPeNDAP clients, including general programming languages and tools such as R, Panoply, and ArcGIS Desktop, and ArcGIS Pro. And also, web applications built by NASA ESDIS, such as AppEEARS and NASA Earth Data Search. And next, I'm going to introduce the OPeNDAP service at the ORNL DAAC. The ORNL DAAC is one of NASA's 12 distributed active archive centers and archives data produced by NASA's Terrestrial Ecology Program in support of NASA's carbon cycle and ecosystem focus area. It's a great source for biogeochemical dynamics related data products. For example, soil, vegetation, hydrology, climate, and terrestrial ecology model inputs and outputs. And it's part of the Climate Change Science Institute at the ORNL. And it provides 3 major categories of data products: field campaign data, land validation data, and regional and global data. And it also archives model codes. And the ORNL DAAC website, daac.ornl.gov, provides useful resources. The implementation of the ORNL DAAC OPeNDAP service is through its THREDDS data server, or Thematic Real-Time Environmental Distributed Data Services. THREDDS data server provides online browsing, visualization, and access for scientific datasets using OPeNDAP, OGC Web Coverage Service, Web Map Service, NetSDF subset service, and other data access protocols. as you can see, OPeNDAP is one of many services provided in the THREDDS data server, and it's a major one. And we receive hundreds of thousands of data access requests and deliver about a terabyte of data through OPeNDAP each month. Now, let's take a look at this diagram. And this diagram shows the structure of the ORNL DAAC THREDDS data server and the OPeNDAP service. The ORNL DAAC data holdings, including field campaign data, regional and global data, and land validation data, are first standardized into climate and forecast convention compatible NetSDF format enriched with metadata information, and then served through the THREDDS data server. Users can then explore and find data of interest, retrieve metadata, visualize data interactively, and access data through different protocols, including OPeNDAP. And also integrate data into their analysis workspace. I will present two demos of the ORNL DAAC THREDDS data server and OPeNDAP service. The first demo is to explore the ORNL DAAC THREDDS data server to visualize and find data of your interest. At the end of the first demo, we shall get the OPeNDAP URL for a remote data of interest, and which will be used in the second demo. The second demo shows how to access and use remote data from OPeNDAP services found in the first demo in your R workspace. So, okay, let me switch to the live demo by first going to the ORNL DAAC website. So from the ORNL DAAC website, on the Tools menu, and we can find a link to the ORNL DAAC THREDDS data server. Click on it, and then we can go to the home page of the ORNL DAAC THREDDS data server. It looks very simple. Those three directories correspond to the three categories of data archived at the ORNL DAAC, and you can freely explore those online directories to see what are available. Let's click into regional and global data, and we see those list of data collections for the regional and global data category. And one of them is DAAC collection. So DAAC is a valuable data product that provides daily weather data over North America at a high 1 kilometer spatial resolution. And let's click into DAAC collection, and we see 3 data sets are included in that collection. And let's click into the first one. And we see all the years in which the DAAC data are available from 1980 to 2014. So let's just pick 1 year, say 1990. Let's click into that, and we see 7 data files available for that year, like precipitation, radiation, temperature, vapor pressure, those common weather data variables. Let's click daily maximum temperature, and it takes you to a page that shows some basic information about the daily temperature data file, along with options to visualize the data and options to access the data. I will not go into details of THREDDS data server in this webinar. There are a lot of resources available online. So let's first take a look at this data by using Godiva 2. It's an online browser-based interactive data viewer. So let's click into Godiva 2, and it takes us to this page. On the left side, there lists the data file name along with the variables that are plottable. Let's click into the daily maximum temperature because this is what we are interested in. And you see the viewer in the middle of this page has been updated to show a daily maximum temperature map for the last day of 1990. So you notice that this calendar, this is the map for December 31st. Since this is the daily data, we can navigate through the calendar to see a different map. That's the different days maximum temperature map. And this is an interactive viewer, so you can freely zoom in and you can pan to see the details. So assume at this moment you are pretty happy with this data and want to use it in your analysis workspace. So let's go back to the previous page and find the remote data URL for this data file. So let's click on the link to the right of OPeNDAP and takes us to this page. It looks complicated, but let's just focus on the data URL box. And this URL highlighted here, this is the remote OPeNDAP data URL for this data metadata file. This is very important. Let's save it for our further use. So now we can move to the second live demo. I want to show you how we can easily use the OPeNDAP data and we just discovered here in your R workspace. So this is the interface for the second live demo. I'm using Jupyter Notebook for this live demo, and this notebook contains multiple sections of R codes, and which we can run one by one for better explanation. This example shows how to access time series of daily maximum temperature at an AppEEARS site location, and then compare it with the monthly climatology data at the same location. So two remote data will be used in this demo. Besides the daily day metadata we just discovered, we also use the global half-degree mean monthly climatology for 1961 to 1990 to give you an idea of how this climatology data looks like. Here is a visualization of the monthly maximum temperature in June. This visualization is also generated by the ORNL DAAC THREDDS data server. Again, you can freely zoom in and pan to see the details of this climatology data. Okay, let's go back to our R demo. So step one here is to load R packages required in this demo. So let's highlight this section and click Run to load the packages. Step two is to define the coordinates for the AppEEARS site that we are interested in. This is a site located in California, and we define the latitude and longitude coordinates here. So let's run this block to define our coordinates. Then we go into the third step. The third step is to connect to the remote data and to retrieve their metadata information. Notice that we have two blocks here, one for daymat data, the other one is for climatology data. And we have two URLs here. The first URL is for the daymat remote data, and the second one is for the climatology remote data. So we are using a function ncopen to connect to the remote data and retrieve the metadata information. So let's run this first block and see what we get. And here we see this is the information just dynamically returned from the server. It gives us description of what's included in this remote data. It says it contains 6 variables, including latitude, longitude, and the Tmax. That's the daily maximum temperature. And we notice that it's a 3-dimensional array, x, y, and time. And the daymat data also contains 4 dimensions and also some useful global attributes. So similarly, we can retrieve the metadata information for the climatology data. So let's run the second block, and we see the metadata information for the climatology data. So now we have step 4 here. To use an OPeNDAP data, a difficult thing is to find which grid cell or cells contain data values of your interest, because OPeNDAP allows data subset through indices. We use a very simple solution here to convert latitude and longitude coordinates, which is defined, into indices of the grid cell. We simply search which grid cell contains latitude and longitude values closest to our site location. To do that, we need to retrieve the data values of latitude and longitude variables from the remote data server. And here we are using a function called ncvar get to retrieve the data values of a variable. So using those few lines of code, we can calculate which grid cell contains the AppEEARS site location for both the day metadata, that's the first block, and the second block is to calculate indices for the climatology data. So let's just run the first block to retrieve the latitude and longitude variable values from the server, and then find which daymat grid cell contains our site. So it took a little while because it actually went to the server to retrieve the data values. And we got the results. That's X and Y. That's the indices of the grid cell. That's a 1 kilometer resolution grid cell that contains our AppEEARS site. So similarly, let's do the same thing for the climatology data. Let's run this block. And this time it's much faster because the climatology data has a coarser resolution than the daymat. So each grid cell of the climatology data is half degree by half degree. So that's the indices for that half degree resolution grid cell that contains our AppEEARS site. So now we have found the indices for the grid cells that contain our site location. The next step is to retrieve the actual temperature data values. These are what we're really interested in. And we, again, are using ncvar get function to retrieve the data values. But here, there are 2 more additional parameters. These are very important. This is start and count, which define the start index and also how many values we want to retrieve on each dimension of the temperature variable. And the first dimension is longitude. The second dimension is latitude, and the third dimension is time. So notice the count here, 1, 1, and 365. This means we want to retrieve only 1 grid cell, but all 365 days of data from the remote server. So let's just run this block of code. And it took a little while because this also involves retrieving remote data from the server. And here is the result. We have 365 values that represents the daily maximum temperature for that particular location in year 1990. Again, similarly, we can run the same thing for climatology data. So let's run this block. And here we have 12 values only because this is a monthly data. So you see how easy it was to retrieve and subset data values from the remote data server. The daymat data is pretty huge. It's gigabytes in size for each file. But you don't have to download the whole file. You can easily retrieve a portion of the data that you are interested in. So now in the R workspace, we have 2 arrays of data values representing the daily maximum temperature and also a monthly climatology that represents the maximum temperature for each month in that time period. This is the mean climatology that represents the mean monthly temperature from 1961 to 1990. So with those data values, we can do whatever we want for further analysis. For example, we can make a simple plot to compare the daily maximum temperature time series with the monthly climatology temperature. So let's run the last block and make a simple plot. And here's the result. On this plot, the red line represents the DAMAT daily maximum temperature, and the blue line represents the monthly maximum temperature. And we can see those two lines have the same seasonality, but the daily maximum has more details than the monthly maximum temperature. So you can see this is a simple demo that shows how to easily use OPeNDAP services in our workspace. Similarly, you can achieve the same thing in other workspaces like Python, MATLAB, etc. So with this, I conclude my demos. And next, Aaron Fries will talk about the OPeNDAP service at the AppEEARS and a nice OPeNDAP web client called AppEEARS. So Aaron?
Thank you, Yashing. As he said, my name is Aaron Fries. I'm a data scientist for the LPDAC, and I'm part of the team that's been responsible for implementing OPeNDAP at the LPDAC and developing some tools and services for interacting with the OPeNDAP. The LPDAC archives and distributes land remote sensing data from sensors on board NASA satellites. We archive data from the Terra and Aqua Modus sensors as well as the Terra Aster sensor. We also archive derived products resulting from NASA proposals. What I'll be talking about is our MODIS archive, where we store nearly 1,500 terabytes of land MODIS data. This data is accessible via our data pool, where you can view browse images and download MODIS granules using unique URLs. What you get when you download from the data pool, as many of you probably know, is a granule at its full spatial extent with all associated bands for a single day or composite period. For an individual interested in analyzing data for a range of dates or for smaller than a granule, the process of downloading and processing these granules can be a little bit tedious. To address this problem, we've set up a Hyrix OPeNDAP cluster that's able to access MODIS data from our data pool. This makes it possible to access and extract discrete subsets of data from MODIS products, meaning that the user can extract spatial subsets, the user can extract specific bands or layers of interest, and since OPeNDAP allows for temporal aggregation, the user can also extract temporal subsets. Requests for data from OPeNDAP are made via URL. Like requesting data directly from data pool, OPeNDAP URLs specify the product and tile of interest. However, with the OPeNDAP URL, additional arguments allow you to specify a layer of interest, a time range, and the spatial extent of the data that you want. And on your screen is an example of a OPeNDAP URL where we specify the specific product in the HV, as well as the surface reflectance layer, along with the time parameter and an XY location. And what you get is a data set that you intend to use without having to spend the majority of your time downloading or processing data to fit your specifications. This is the URL from the previous slide, and if you would put this into your browser and request data directly from OPeNDAP, you would get this, this return below. And so what this represents is it just shows that in dealing with the URLs and the return data, things can get a little bit complex. So as you can see from the example, OPeNDAP calls require a level of familiarity in terms of how they are composed. As with most URLs, the user must understand something about the syntax. The user must also know about how the product name, the layer name, and how time is represented in OPeNDAP. Also, the user must know the specific tile, HV, or the pixel location, the XY, of specific coordinates. And this can be a pretty daunting task, assembling all that. And so this is our architecture at the LPDAC, where we have the data pool on the right side and the user on the left side. And then we have our OPeNDAP cluster set up right next to our data pool. And using that URL, you would be bypassing this middle section and going directly from the user to the OPeNDAP to make your calls. What we've done is, and continue to do, is develop some services and tools that allow you to, the user to more easily request data from OPeNDAP. These services and tools provide a link between the user and OPeNDAP, relieving the user of the hassle of constructing these URLs, and it returns tidy analysis-ready data back to the user. We took this attempt to simplify the interaction between users and OPeNDAP one step further by developing a web application that utilizes the full capabilities of OPeNDAP and our services without users having to get their hands wet. It's called the Application for Extracting and Exploring Analysis-Ready Samples, or AppEEARS. And what we think it provides is an intuitive and useful way to extract and explore data values from Modis tile products for specific point locations. And AppEEARS is built on top of our services and tools, and it provides access and easy selection of Modis products within our archive. It allows you to extract pixel values for specific point locations, gives you the ability to explore and interact with your data before download. And should you choose to download, we have a nice little data bundle that you're able to download. And here's an example of that data bundle where we have a README text file giving you some indication of the processes that happen behind the scenes. We have this granule list that gives you a list of granules, or every granule that you touch during a request. And so you can take this file and dump it into DAAC to disk and acquire all of those granules that you requested earlier. We have the data files in CSV format. So we have one file that contains every data point, data value that you extracted. And then we also have CSVs that are broken up by the product type. And then we have this nifty little JSON file that you can take and you can share with a colleague or some other individual, and they can take that file and drop it into our AppEEARS application and get the same exact request that was run by you. And so at this point, I'd like to move to the demo and show you what it's about. So this is our AppEEARS landing page. It is tied to your URS login and password. So if you don't have one, get one if you plan on using AppEEARS. We have this help tab that you can click, and it gives you step-by-step instructions on how to get started with a request, perform extractions, view your sample, and interact with your data. We have another part of this help document where we have our available products list, and it contains every layer that's available through AppEEARS currently. And so if it's not available, we are currently working on getting those assimilated into our AppEEARS. And so let's move to extracting a sample by clicking the Extract tab and clicking on the point sample. You'll be taken to a screen with three options. You can start by starting a request from scratch. You can start a request by copying a request that you've done in the past, or you can take that JSON file I was talking about and dump it into this third, or the far right section, and get the same request as a colleague. And so let's do a request by making a copy of one. Your first field that you would fill in is your sample name, and this is tied to all your output files that you would download. The second field is the coordinates, and you can do this by either manually entering your latitude and longitudes for each coordinate, or you can dump in a CSV file. You have the two additional options of adding either a site ID and a category, and they must be on the left side of the latitude and longitude coordinates, and everything must be comma separated. The next field that you would fill in is your date field, and you have two options. You have the option of putting in a start date and an end date, or you can click this is date recurring and do seasonal extraction. So if we wanted something for the summer, we can select the summer months and extract the sample for a specific year range, and then you would move on to the next field. And so from here, you would click you'd specify the layers that you would like to take samples from. And so all you do is start typing either the MODIS short name or long name, and it will bring up the products that we have. Click into the product, and it will bring up all the layers that we have for that product. All you do is click on the layer, and it sends it over to the selected layers field. You can also, from here, remove any layers that you currently have in there, or if you've made a mistake. You have the ability to put multiple or make multiple layers from different products within this area. And so if we wanted something like land surface temperature, we can start by typing a keyword in the long name and select that product, select the layer within it, and then when we're satisfied with the layers that we've selected, we would click the Submit button. If you have a successful submit, you'll be taken up to the top, and it'll give you a banner saying that you did it right. If not, you get this red box and red letters saying that you didn't do it right. So fill in that correctly and click Submit again, and there's our banner. To get to our data, we have to click this Explore tab. It takes you to a screen where it tells you the status of the sample that you've submitted, as well as any sample that you've done in the past. We have the details of an individual request that you can look at. From here, you can delete a request if you wish. You can download from here, or you can start to view your data without downloading it. So let's do that. So again, we have the option to view the details of this particular sample that I clicked. You have the ability to download. You're taken to a screen with 3 tabs. Our first tab that you land on is our temporal comparison tab, or our univariate view of the data. And so for a particular site, for a single layer, it gives you a time series of that data. And we have the ability to filter the data based on good quality pixels, which are defined by the Modlin quality bits. Here we have 3 visualizations. We have one, the traditional time series, where it goes from start to end. We have a stacked time series below that, where we stack each year on top of each other. And then we have the data table with all the data points that we've extracted for this layer. These are connected, and so if I'm interested in this range of data, it will filter down to this date range, and it will cause a reaction in the further, or the other 2 visualizations. You also have the ability to have a pop-up help where it gives you the data value and the quality for individual pixels, and you can add a line if you wish, which is just a connect the dot line, and then reset is right here. Moving on to our next tab, it's our layer comparison tab, where we do kind of a bivariate analysis for a single site. You can specify the site, you can specify the layer that you wish to look at, and again, we have the quality functionality here. Again, we have 3 charts on this tab. We have a time series with the double y-axis to compare between layers. We have a scatter plot, and then we have the data table once again. Again, they are connected to or linked to each other, so filtering the data down here or zooming into the data will cause a reaction in the bottom 2 visualizations. Again, you have the help pop-up in both of these charts, and you can turn on and off these layers if you wish, and you can add lines again too. Our final tab is our categorical overview, where it contains a series of box plots that give you an indication of the distribution of your data within categories. And so by default, we have a quality breakdown of all your data points within. It gives you the statistics that are normally associated with your box plots. We have, in this case, we have 3 visualizations again. You can also, or all these visualizations are connected again, linked. And so if I'm only interested in my Modlin 0 bits, I can click on that, and it will filter down through my other box plots only showing data that has Modlin 0, and I can also continue to filter based on other categories. And so With that, I'd like to end my live demo and hand it over to Matt.
Thanks, Aaron. This is Matt Tisdale from the Atmospheric Science Data Center, and I'll be discussing some tools that you can access OPeNDAP services in. So first off, I wanted to go over the ASDC at a glance. The Atmospheric Science Data Center has an archive of over 4.1 petabytes of atmospheric science data and distributed this to over 624 terabytes of last year to 158 different countries. The ASDC focuses on processing, archiving, and distribution in the areas of the Earth's radiation budget, clouds, aerosols, and tropospheric chemistry, as you see below. The ASDC currently has a HYRAX OPeNDAP server that provides access to MOPIT, TESS, and MISR data products. The ASDC is currently upgrading to the latest HYRAX OPeNDAP release, and will be adding Calypso and series data products to those that are already available. So you see the list here will be growing across our OPeNDAP instance if you come to our data center. So today we'll specifically be discussing a few client tools. We're going to discuss the Earthdata Search Client, Panoply, ArcGIS Desktop, and ArcGIS Pro, and how you can use OPeNDAP services in these. A few of these are, the first one is a NASA tool and Panoply as well, and ArcGIS Desktop and ArcGIS Pro are commercial applications. So you can start to see that a lot of different applications, commercial, open source tools are allowing OPeNDAP services to be integrated with them. So the first tool that we'll discuss is the Earthdata Search Client. That's available at search.earthdata.nasa.gov. The Earthdata Search Client provides access to ESDIS services for data discovery, filtering, visualization, and access. So we'll now go to a demo here showing the first page here when you come to search.earthdata.nasa.gov. And now we want to browse all data. So we'll click on the Browse All Data button. It'll take us to this screen now where we can start to search for data that we may be interested in. If you notice at the top left corner, there's this Features button that'll drop down. So we'll click on that. That shows us what features we can select to filter data to just those features that are available. So in this case, we're interested in OPeNDAP services, so we're going to click the Subsetting Services button to see what data is available through the subsetting service. When we click that, now the data is restricted to just those that provide those subsetting services. So these are all the services that are available with OPeNDAP connections on the back end. So if we click on the first one here, AIRS Aqua Level 3 8-Day CO2, we'll be brought to this screen. So now we can start to do some spatial subsetting if we want, if we're only interested in a particular area. So we can click on the spatial drop down at the top and draw a rectangle of our area of interest. So if we're only interested in a small area in North America, we can highlight that. And then we can click to download that data. So now we'll click on that blue button there to retrieve a single granule data. Once we do this, we'll be prompted for our Earthdata login. So at this point, you either can put in your Earthdata login credentials, or if you do not have an account, it'll prompt you to the location to go request that account. And then you can use this across various NASA applications for a one sign-on experience. So we'll click here to put in our username and password, and then click Login. We'll be brought to this page now. And so now it's actually, when we click this download button, the radio button right here, for select data access method, it'll provide us with different formats that we can get this data in. So right now it's actually going back to the OPeNDAP service that's available for this data product. And we can select if we want the original file, if it was stored potentially in an HDF. But now we can also get that as a NetCDF or an ASCII data product, which wasn't available beforehand. So it'll do that conversion on the fly for us. If we scroll down a little bit further, we can see some other options that were available. So that spatial subsetting that we selected here in North America is available. We could also go back to the full scale. If we want to look at the entire world view of that data set, then we can download that as well and uncheck our subset that we drew in that spatial search. And then below, we can see all the parameters that are available for that data set. So if we're only interested in one of these out of the three, we can specify just to get that one. So this reduces the amount of data that you have to download if you're only interested in a few parameters out of those data products. In this particular case, we only have 3 parameters, but you can imagine if there was hundreds, this would be a very easy way to start to subset your data to just that you're interested in. And then you can click Submit, and it'll actually generate a URL to then go and get just that data that you're interested in for that spatial area and the format that you want and the parameters that you're interested in. So now that we looked at the Earthdata Search Client, we'll look at another application known as Panoply. So Panoply is an application that plots NetCDF, HDF, GRIB, and datasets served by OPeNDAP. And we can view these in the Panoply application directly through the OPeNDAP service links. So here we'll open up Panoply, and then we'll click the drop down here for File, Open Remote Dataset. And similar as you saw in the presentations before, you can get that data access URL to any one of those data granules that you're interested in visualizing or accessing. So here we would type in those same URLs that were used in the previous presentations to access a particular data set. In this case, we're being prompted for our Earthdata login credentials. So if the OPeNDAP service has an Earthdata login in front of it, we'll have to put in our Earthdata login information, similar as we did for the Earthdata Search Client. Or if the service doesn't require it, then it'll automatically just connect to it. So here we've made that connection to the OPeNDAP, and we can see here we have a data product, and it's listing all the parameters that are available for that data product. So now we want to do a visualization of one of these, so we'll just scroll down, and we see Retrieve Surface Temperature here. So we'll right-click on that and create large plot. Once we do that, we'll be presented with some more information. In this case, this is only a latitude and longitude. There's no height or time information. If there was, then we could select that as well to describe how we want to do this plot. In this case, we just want to visualize it as it would be on the globe. So we'll do a longitude-latitude plot and click Create. And this actually just went back, connected to that OPeNDAP service, and rendered this image. We never actually had to download any data locally to our desktop. This was all done through the service. And it pulls information, so you can see it pulled the title there for Retrieve Surface Temperature, displays the data, creates the color ramp bar for us. So it's a real easy way to start to access these services to create nice visualizations that you can add to your papers or research, or to begin investigating the data before actually downloading it. So the next application I want to discuss is ArcGIS Desktop 10.3.1. So ArcGIS provides the capability to view multiple geographic data sets in one view, perform complex analysis, and analyze patterns within those data sets. So one of the first things that we have to do before accessing the data is download this multi-dimension supplemental tools. If you Google multi-dimension supplemental tools, it'll take you to this page where you can then download by clicking the Open button to download the package to begin working with OPeNDAP in ArcGIS 10.3.1. It's not a native capability. Once we go here, we'll be presented with this folder on our desktop. We can click this netcdf4 file here, the .exe, run that, and it'll actually install the tool. So it's pretty simple and straightforward install to get this working. Once we have that, we can open up ArcGIS Desktop, and then we'll navigate to that folder. Here you can see the multi-dimension supplemental tools folder. Below that is this toolbox, and now there's this OPeNDAP to NetCDF tool that's available there at the bottom. So if we double-click on that, we're presented here, similar to what we saw in Panoply. We can put our OPeNDAP dataset URL here at the top. We can select what we'd like to visualize, what variables we'd like from that service. Here we're going to just do Retrieve Surface Temperature, daytime again. And then we can name our output NetCDF. So this is going to reach out to the OPeNDAP service and download a NetCDF that'll work in ArcGIS a little bit better than the HDF file originally. So we'll hit OK to run that. We could also specify an extent if we only want a certain area for that file that's returned. So similar to with our data search client, if we only want a particular area of interest, then we can note that in these X and Y maximum and minimums here to get that particular area. So we'll click that, hit OK, and then it'll run until complete, and then we'll close that window. And now that we have that, it just downloaded a NetCDF file to our desktop that we can start to integrate with ArcGIS Desktop. So now we can go to Input NetCDF File, select that file that was just generated, what variable we want to visualize off of that, fill out the other information, what you'd like to call it within ArcGIS Desktop when it displays in the layer list, and click OK. And we've just pulled in that data now into our ArcGIS Desktop. So now it's treated just like any other layer within ArcGIS, so we can start to do our own analysis or layer other types of data on top of this. And just to show that this is, in fact, georeferenced and spatially accurate, we'll go ahead and add an Esri base map on here just to show the two overlaid on one another. So we'll click on the plus arrow here and go to Add Base Map and select Imagery. And we'll click Add. And now that we have that added, you can see the layer overlaid on top of the base map, and that North America, Africa, and the other continents are lining up pretty well right on top of our data. So we can start to add other data sets to this as well. We could also start to do analysis with all the ArcGIS toolbox tools you see on the right side. So there's a lot of capabilities that this now brings to being able to access these types of data in these different software tools. So one of the other things I wanted to show is that recently released ArcGIS Pro 1.1. So as before you saw, there was quite a few steps that we had to go through to generate that NetCDF as an intermediate product to then pull into ArcGIS. What Esri's been doing that makes ArcGIS is really trying to directly access that OPeNDAP data into their tool. So we'll show a new tool coming with this ArcGIS Pro 1.1 release. And here we have it loaded up. So we click on similar, we go to the toolbox and search for this geoprocessing tool called Make OPeNDAP Raster Layer. So this will skip a lot of those steps that we saw before in the desktop that we had to go through. So right now we can just put our input OPeNDAP URL, we can select our variable, what we want to call that output layer, fill in our extend information. If there's any time or height information, we can select that out as well. And then hit run, and this will just go ahead and put it right into our map. So we don't have to create that intermediate product. It'll just go reach out to that OPeNDAP service and pull it right into your map. And then you can start to do any kind of analysis or overlays of data now. So this simplifies the process quite a bit with using ArcGIS Pro with this. And this is just a sample of some of the applications that you can use with ArcGIS and integrating OPeNDAP services. And with that, I'd now like to turn it back over to Jennifer.
Okay, thanks, Matt, and thank you, everybody. What we'll do next is we are going to move to our final set of polling questions. And I will give these questions just a minute or so, and then we'll move directly to the Q&A portion of the webinar. So make sure that you stay in the room and or on the line to participate. All right, so we'll give these just a couple minutes here. Okay, we're going to give this just a couple more seconds, and we will move directly to the Q&A portion. Okay, let's move next to our Q&A portion of the webinar. And I did actually have a couple of questions earlier here, so I am going to go directly to those. The first question today is, do you need to install a specific package in R to access data via OPeNDAP? So either Yashing, Matt, or Aaron.
So this is Yashing. Yes, you will need a plugin called NCDF4, and that contains all the functions you need to access a remote OPeNDAP service.
Okay, thank you, Yashing. Our next question is, are there meteoclimatical data available for non-U.S. areas? Okay, anybody? I believe this question was asked during the DAMET portion of your demonstration, Yashing.
This is Yashing. The DAMET data is available for most area of North America. Right now, the current DAMET release is available below 52 degree north. But the second version, the next version of the DAMET will expand to the whole North America. So the next version of the DAMET will be available for a bigger extent. But for the rest of the world, that's probably more in the future.
Okay, great. Thank you. So before we move to the next questions, I just wanted to make a couple of points. The first one is that this webinar was recorded for those of you who are inquiring, and I will have it posted both to our online catalog, which is the tinyurl.com Earthdata webinar, as well as to our NASA Earthdata YouTube channel within a couple of days. So probably by Thursday, this will be posted online. If you access it on the online, within the online catalog, the feature to be able to download the presentation files is persistent. However, that is not true on the YouTube channel. So below in the lower right-hand corner of your screen, if you were to highlight any of the presentations, you would then be prompted if you left-click to download those files. So if you access it at a later point by way of the catalog, you would still be able to do that, okay? So now let's move to the next question, and the next question is, where can we access AppEEARS? So Aaron?
Sorry, I was trying to get unmuted. If you go to the URL https://LPDAC SVC, or it'd probably be easier if you go to the last slide of my presentation, Jen.
Okay, you want me to do that now?
Please.
Alrighty. Let's see here. Hold on a second, everybody. You know
And
what,
that's where you can get to AppEEARS.
I'm actually going to type this into the Q&A pod for everybody. Okay, so hold one moment. Okay, so you should see that now, everybody. I have typed the URL in, and someone else has as well. Okay, so yes, okay, let's move to the next one here. If we have a problem accessing OPeNDAP on the data server 3, and all of you can see this URL, .nccs.nasa.gov threads, who should we contact? So, Yashing, do you have feedback on that, any of you? Hello? Yashing, are you there?
Hi, Jennifer. This is Yashing. Could you please repeat the question?
Okay, so the question is, if a user has a problem accessing OPeNDAP by accessing it through the URL, which you should be able to see right in the Q&A pod to reference this if you click on Presenter View. It's the dataserver3.nccs.nasa.gov/threads. Who should we contact?
I would recommend that you can go to the NASA ASDIS website and try to find the Contact Us link there, because this is not a service that's directly related to the ORNL DAAC. So I would recommend to go to the NASA ASDIS to contact support there, and they will distribute your inquiry to the appropriate location.
And just an additional note, I can also follow up with this end user directly offline and send an email with this information as well, okay? So I will contact you when we are finished here and follow up so that you've got a record of the answer to this. Yes, the webinar was recorded. It will be available online. The slides are posted. Let me move back to the end here. The slides are posted here. And in the bottom right-hand corner of your screen, you will be able to left-click David, and you will be prompted then to download those slides. And I will also leave the meeting room open an additional 10 minutes or so when we're finished, just for those of you who are interested in possibly downloading during that time period. The next question is, will the SRTM data, specifically the 30-meter data, be available on one of the servers? If so, which one?
This is Aaron. There's no plans to include that data set in AppEEARS right now.
Okay, thank you, Aaron. So there's a follow-up to the question asked just a moment ago as far as issues with the THREDDS data server. And again, this may be something we just need to follow up offline with. The further details say that the problem is that the server sends partial of the data and the netcdf library gives segmentation fault error. So Yashing, I believe that this is something perhaps you might be able to address, or is this something we should just follow up with offline?
Yes, please contact me directly.
Okay, so Mohammed, I will follow this up when we are finished, okay? And apparently I had a typo with the AppEEARS URL that I posted, and so the correct one, which is the LPDAC csvc.cr.usgs.gov/AppEEARS. And again, it will be in the presentation, so you'll be able to reference that later as well. So thank you for the correction, Kevin. Yes, okay. That's why some of you are not able to open the URL. Can data be ingested via REST API?
This is Yashin. Yes, definitely, you can.
Okay, great. Thank you. The next question is, what storage schema do the data pools use, and how does the OPeNDAP cluster access them?
So I'll say a little bit about the ORNL DAAC OPeNDAP server. And I think the OPeNDAP server can support a wide range of storage schemas. And for us, we have a high-performance storage system attached to our server. And that's where the THREDDS data server serve the ORNL DAAC data holdings through multiple services, including OPeNDAP. I think it's pretty flexible. You can even install THREDDS data server and set up an OPeNDAP service on your own local computer.
Okay, great. Thank you, Yashing. So we do have a LPDAC representative also listening into the webinar, if not more than one, and there's a clarification here regarding SRTM data availability, and the clarification is that 90-meter SRTM data is available at the LPDAC's OPeNDAP site. And then further, she notes we do not have any current date yet to deploy the 30-meter data on OPeNDAP. So thank you, Danielle. Okay, any further questions?
Jennifer, this is Yashin again. I want to mention a little bit about the 30-meter SRTM data. The ORNL DAAC has another application called AppEEARS that contains an earlier version of the SRTM 30-meter resolution for the whole U.S. And you can also do visualization and subset for SRTM data through the SDAT application. And if you want to know more about that, you can feel free to contact me directly.
The other thing I'll do when we're finished is I will actually insert the URL for the SDAT tool at Oak Ridge DAAC. So when we've finished our questions, I will type that in for everybody. And just an additional note, the Q&A log, which contains some of these more specific questions that participants have asked, is captured and sent along to the speakers. So, you can also be in contact with them directly on any of these questions which require, further clarification. Are there any additional questions at this time? Anybody? Don't see any. We'll give it just another minute or so. Oh, but hold on one moment here. Yes, I will do that, Nicholas, no problem. So at this particular point in time, what we will do is if there are no further questions, we will log off from the telecon, so you will no longer hear audio. However, certainly if you have any questions, please feel free to type those